I hear doctors talking about this, that cancer comes from dying
just
mutated
cells that go with Alzheimer's, wacko, murderous.
Yeah, but what Nicholas Gonzalez discovered here is that cancer does not develop as so long thought from mature healthy cells that suddenly go molecularly berserk, transforming into cancer. Instead, cancer develops from stem cells that lose their normal regulatory restraint.
Right. Hey, everybody, it's Dr. Jack.
And Mary.
And this is the Forbidden Doctor Podcast, episode 111.
That's a lucky number, 111.
Yes. If you have cancer, no doctor will tell you this.
And by this, we mean what we're going to tell you in our podcast.
Absolutely. So 3 years ago, I had a scan of my abdomen because of some very severe pain. And as it turns out, the report said that I had an atrophic pancreas, a wasting away pancreas. I had problems with my pancreas. We've talked a little bit about this in podcasts before. We're going to get into a different version of the whole idea in this particular podcast. However, I just had another scan, which is essentially 3 years later, last December, and it said that my pancreas was fine, my liver is fine, my intestines are fine, my kidney is fine, and that is going to be the net effect of the process we're going to talk about in this podcast. Well,
as you know, pancreatic problems can be very deadly. That's why we have the slide here, life or death, because it's a very thin line between life or death with any pancreatic problems. So
with that introduction, let's plow into it. So this podcast is made possible by the sales of the Forbidden Doctor's Whole Food Supplements, Long Life Energy Enzymes, and Ageless Thyroid. For those of you that continue to purchase these supplements, we are greatly appreciative. It makes these podcasts possible.
And I always say, enjoy the peace that comes from foundational healing rather than the useless frustration of managing symptoms.
Yes.
So this week's weekly feature, Forbidden Secrets They Don't Want You to Know. These are the secret things they keep from you, the dumb things they tell you, and the really important things they know nothing about. Just real quickly, we just had a couple more sad heart attacks with actor Bill Paxton dying because of heart surgery. Very, very sad. He was younger than you.
Yes.
Yeah, and we talked about the actor Alan Thicke before, and that heart surgeon, the cardiologist there on the right, who gave no other advice for your heart except for to get to the hospital fast. We just hope you can get here fast.
Yes.
Nothing about rebuilding your heart or anything to really prevent it, except if you have a family history of heart problems, then just stay really close to a hospital. So that's kind of sad. And then down at the bottom, this guy, Bob Harper, did not die, luckily. But he's been a fitness guru for years and years. I suppose many people heard about this. And he had a heart attack in the gym.
Yes.
And just absolutely impeccable shape.
Lots of athletes have serious heart problems during the performance of their event.
So we're not going to go into this much. It's just very sad, the things they know nothing about, that in 2017, heart problems like this and beautiful, incredible people like this are just dying right and left. And these are just famous. You know, the important ones are your grandmother and your mother and your sister and your brother and this. But we just invite you to go listen to this podcast, number 89, LBJ Should Have Had This.
Not em&gt.
Yeah.
Okay. This webinar podcast is not intended to be a diversion away from the current system of disease management. It is our intention to offer a rational and very effective approach to aiding your body in its ability to rebuild and heal. Please be advised that any suggested nutritional advice or dietary advice is not intended as any primary treatment or therapy for any disease or particular bodily symptom. Nutritional counseling, supplement vitamin recommendations, nutritional advice, and the adjunctive schedule of nutrition is provided solely to upgrade the quality of foods in the patient's diet in order to supply good nutrition supporting the physiological and biomechanical processes of the human body. And we're going to be talking about enzymes.
Yes. Enzymes, they are just life. And they're very, very foundational. And that's why we decided to make the product, our long life energy enzymes, to try to reset your body on a foundational level.
There is no energy produced in the body without enzymes. In fact, very little happens inside a living human being without the action of enzymes taking place every nanosecond of your life. Nano being a billionth. And every single cell in your body, enzymes are working. They're found in all cells, as I just said, yes.
All living cells.
They're made of proteins. That's important.
We'll explain that a little bit later.
They're biological catalysts. A catalyst is something that makes something else happen without being consumed itself.
Ooh,
yes.
Fusion energy.
Something like that.
Because we're not plugged into the wall. Is that it? We just keep on working. Really cool stuff.
They speed up reactions, and we'll give you an example of that here shortly. Some enzymes are unchanged by the reaction. That's the catalyst part of it.
That's the never-ending part. That's
Yes.
really cool.
And just, this picture on the left, this Christmassy looking, almost Pac-Man type thing, all those little balls there represent protein structures for an enzyme. Enzymes are very large molecules. And here on the right, with the Pac-Man kind of picture, you have the enzyme and the substrate is what the enzyme is working on. And so an enzyme can only work on a certain kind of substrate in a certain part of the body, which is why we have thousands of enzymes inside of us.
Right. This is a metabolic enzyme.
This is a metabolic enzyme. You see the enzyme now is bound to the substrate in the middle. And in the third picture there, the enzyme is now free, but the product is different than what it started with.
Because you have a diamond.
Yes, instead of a triangle,
I like diamonds.
you now have a diamond.
Girl's best
now,
friend.
a good example of this is deiodinase enzyme that converts T4 to T3. T4, those of you who know anything about the thyroid or have listened to our podcast on the thyroid know that T4 is the storage form of thyroxine, the main hormone of the thyroid. T4 levels, T3 levels are very, very important inside the body for the energy to get up and go and the things that just keep our metabolism where it's at, moving forward so we can enjoy life.
And so this little fusion energy, this enzyme comes into play like the deiodinase. Boy, we should name a kid deiodinase. It's kind of pretty.
Yeah. Anyway, T4 is the storage form of thyroxine and it's stable. That's why it's the storage form. Your body can use T4 if the T3 levels get low, but
it's slow.
It's a slow use of that kind of energy. And T3 is a more unstable molecule. And as such...
But it's kind of explosive, so...
Well, as such, it's only created when it's needed. And this takes place in the cell. And there is an enzyme...
Called...
Do you want to say it?
No, because did I slaughter it last time?
Deiodinase.
Deiodinase. No, maybe that's not
this is, you're going to pronounce about every syllable there. We'll convert T4 to T3 in that little picture that's above you, where the T4 is the triangle and the diamond at the end is the T3, and that happens in a nanosecond.
It's life. That's what it is. We're going to talk, though, about 3 different types of digestive enzymes. And this cute little chart just shows you the substrate, in other words, the thing that's changed by the enzyme.
And what happens to it after the change?
So you have a protein you eat. The enzyme protease comes in, chops it up, and into a bunch of amino acids. Same with carbs. Amylase comes into play, and it chops it up, and you get maltose. Fats, lipase, it's kind of the way I remember it, chops up fats or emulsifies them into fatty acids and glycerol. And here's another chart that explains it. It's a little more visual.
There you have the protein molecule that's made up of many different amino acids.
The cute little colored chain.
Protease hits it and breaks it down into amino acids.
Separate amino acids.
Because you can't have proteins in the bloodstream. So we eat protein because protein has to be a part of our daily dietary intake. And regardless of the source of the protein, you can't have proteins in the bloodstream. That's what causes allergies. In fact, it's the only thing that causes an allergy is a protein in the bloodstream that shouldn't be there.
Got him by your leaky gut.
So the digestive system takes these proteins and breaks them down into amino acids.
If you have enough protease.
The amino acids go through the wall of the gut into the bloodstream and distributed throughout the body. Cells pick up through their cell wall these amino acids and reconstructs proteins inside the cell.
So cool.
As directed by the RNA that got its signal from the DNA to make this kind of a protein or that kind of a protein inside the cell.
So you can heal your ear. You can rebuild that artery.
Your kidney can function, your liver can function, the thyroid can function, because these things are constantly taking place. But you also need glucose. So we have a starch molecule that's made up of many glucose molecules. Starches are just long chains of sugars. And so carbohydrates or amylase breaks down these carbohydrate molecules into glucose, which is really the only sugar that your body can use. So whether you are, it doesn't matter what ose is on the end of a word, sucrose, galactose, maltose, dextrose, fructose, at the end of the day, they all become glucose before your body can actually use it.
So we have to break that Death Star down into glucose. See,
that's it.
The galactic glucose. And it says carbohydrates there, but most people know it as amylase.
Well, there's a lot of different kinds of enzymes. We're just talking about the three major ones here.
Yeah, we're trying to make it simple.
And then a fat molecule is made up of a fatty acid and glycerol molecules.
And the glycerol is what holds the fatty acids.
The three fatty acids. That's a triglyceride. Tri meaning three, and a glyceride, it's a product of glycerol. And lipase breaks those down into fatty acids and glycerol. And those fatty acids have to be delivered to the cells as well, but you can't have fats floating around in water. So the liver wraps them up in a protein, and it's called LDL.
LDL.
And it's shipped out of the liver.
Lipoprotein.
Yeah, fat protein.
LDL.
Low density.
Low density, that's what I'm missing. Low density lipoprotein.
Yeah, and that's how fat's distributed throughout the body.
Okay.
And it takes the enzymes to do that. So what do enzymes do? Well, one of the things, they maintain normal endothelial, which is the inner lining function of the blood vessels. In other words, enzymes are constantly moving through the bloodstream, scouring the walls of the blood vessels to try and keep them clean. That's one of the things they do.
That little thing.
That little bit,
That
yes.
little thing right there. And our cat here, I don't know if you can hear. Little Lucy.
She wants to be a part of the show.
Every time we start our podcast, she comes here and just starts jumping
That
everywhere.
little harmless meow, translated is, feed me.
She ate a mouse today or a rodent of some sort.
Yeah, it's finally warming up. We let her outside, out there on the deck.
Can you imagine her stomach acids to break down? Talk about
raw mouse.
All the bones, everything.
Oh, you can hear the bones crunching when she bit its skull.
Rourke was screaming. And then she went right to sleep, just like most men,
Yeah.
right after eating.
Yes,
they
go
fall
right to sleep. Okay.
Okay, enzymes also help in digestion.
Digestion cannot
of course,
work without enzymes.
Just talked about. Breathing, that important little thing.
The gas exchange inside your lungs is enzyme dependent. The movement of blood throughout the system, what's going on in the heart.
Circulation.
The electrical signals, the muscular contractions, all triggered by enzymes.
Fighting disease.
Yeah, the immune system and what it's doing. The oxidation, the work of macrophages, the liposomes, all these different lysosomes.
All dependent on enzymes.
Enzymes.
Inflammation.
Yeah, your body will use enzymes to mitigate inflammation.
Or maybe help it out and, mitigate it. That's a better word. Detoxing, that's real important. Nutrient assimilation, of course, we talked about that. Breaking down fats, proteins, and sugars. Immune response, we actually did talk about that. And cognitive acceleration.
Yeah, the ability to think quickly. It's all enzyme dependent.
Yeah, very, very. We've had so many people taking our enzymes saying they can think better. Isn't that the coolest thing? And then many that were starting to get dementia or just short-term memory loss has been really helped by that.
Then enzymes are, simply put, very large molecules that cause a certain chemical reaction to speed up or slow down. It's something called activation energy. In other words, a certain amount of energy is required for something to happen. Like you are sitting there and your son hasn't done the dishes.
Which is true, actually.
And he's just sitting in their chair staring at Bob's Burgers on TV. And sometimes you have to go up to him beside his head and, that's activation energy.
Or it takes a lot of energy or effort to lift a bale of hay. I mean, look at this poor guy. Suppose when you lifted it, someone came along and lend you a hand and lifted it much faster. That's what an enzyme does. It speeds up a reaction by lowering the energy required for the action to occur.
Yeah. So he's trying to lift that bale into, say, the bed of his pickup truck. Mm-hmm. But if somebody else was there helping him, that would be the effort of the enzyme to make the reaction speed up by lowering the energy required for it to happen.
Wow. Sounds pretty important.
Yeah. Okay, so here's lysine. It's amino acid, but it's very important because enzymes are long-chain proteins. Proteins, of course, are made out of amino acids. And these enzymes take on certain shapes and are a key to unique locks throughout the whole body.
Yeah, and proteins are really cool. They're the only thing in all of nature that has self-generating movement, like that fusion energy I was talking about. But they do all kinds of things. They lay flat, they fold, they twist, depending on the environment they're in, if it's alkaline or acid or wherever they are in the body.
Heat.
Okay, heat.
But these things will trigger an enzyme to literally move and fold.
So cool.
Nothing else in all of nature can do that. Everything else that moves has to be moved. They don't have independent movement. Enzymes do. Proteins do.
So depending on the environment they're in, that's what makes them active or inactive.
And that's what can activate or inactivate an enzyme.
Yeah.
Not just its
Changes
environment,
their shape,
but the activation of the protein that the enzyme's made of.
Yeah. So you had a great example about waves and tides.
Yeah, we just recently returned from the Pacific coast, and there's a couple of places where we would stop the car and walk out and just watch those beautiful waves pounding against the beach. So did the beach change? Well, yeah, it's changing all the time. Sand gets thicker, gets thinner. The driftwood and other things washing in from the ocean build up on the shore. Did the ocean or did the shoreline change? Yeah, but did the shoreline change itself? No. There's something working on the shoreline to make it change. The waves, the weather, the wind. Did the wind make itself blow? No. Weather changes triggered by the sun make the winds blow. Did the waves make themselves wave? No. Tidal changes, current changes, and the weather itself triggered again by the sun. Did the sun make itself hot? No. Fusion energy inside the sun made itself hot.
So where
all
the
these
chicken
things,
or the egg? Which came first?
Well, all these things require something else to make it happen. But proteins don't need that. Proteins literally can change their shape based on environmental influences around it. pH changes primarily, temperature changes, and nutritional changes.
Which we're going to talk about.
And when a protein moves, it becomes active. When the protein, whatever that protein is made of or is making up, whatever the thing is we're talking about that's made of these proteins, become active when that change is initiated by the protein itself causing the change. Fascinating thing about biochemistry. And so their job is simply to carry out very specific functions throughout the body, just as this key will only work in that lock. That lock will only work with that key. You can put a lot of different keys in there, but it will not unlock. You can throw all kinds of enzymes into a particular mixture, but only certain enzymes will cause certain things to happen at certain places in the body.
And that orchestra has to be
And if I remember right,
beautiful.
It does. It has to be. And if I remember right, I think they've identified over 6,000 enzymes in the body, and that's the beginning.
Was that from your schooling, like 150 years ago, or
149? Don't exaggerate.
No, I mean that's really cool.
Yeah. And so here we have what it looks like an Idaho spud. It isn't. It's a human pancreas. And you see here the pancreas is hungry to get the job done. And most of the digestive enzymes are produced by the pancreas and therefore are called pancreatic enzymes.
Enzymes in plants are there, though, to digest the plants when we eat them. And this is really important. because we're going to have a podcast in a couple weeks about antioxidants, because it is just such a politically correct, I don't know what the word is, buzzword, everything else, marketing. And the antioxidants are in those plants to protect the enzymes because they're easily oxidized. And when we cook those plants, the enzymes are destroyed along with the no longer needed antioxidants.
Yeah. But even with that, the minerals are still there. Some of the vitamins, some of the enzymes remain. And this is why plants have a cleansing and detoxifying effect in our bodies.
Yes, but we need the minerals and we need the vitamins, but we don't create the enzymes inside of us to break down these plants. So sometimes they need to be cooked in order to get that vitamins and those minerals out of there. But these plants that I'm showing you right here, some of them are cruciferous. One of them, I don't see any broccoli there. They have a cleansing and detoxifying effect, and that's really important in our bodies. So if you juice a vegetable and drink it right away, it's the way to get the maximum of benefits from that vegetable. Or you can dry it and crush it, as Standard Process does with their cruciferous complete product they have.
Broccoli and kale.
Yeah, and it's cold process. That's very important. It's not heated. Now, here's something that's important. The longer a vegetable has been picked from the vine, the longer it's been oxidizing and losing its strength. So, obviously, not everyone has a backyard, year-round organic garden. So, when shopping for vegetables, buy the freshest and, of course, organic varieties you can find, because the enzymes will still be intact.
Yes.
So, as we were talking, there are three basic types of enzymes: digestive, plant, metabolic. We talked about the plant and a little bit about the metabolic type enzymes.
Deodorinase that breaks T4 into T3, that's a metabolic enzyme.
Yeah.
We're going to be talking mostly about digestive. These are the extremely important in our daily life because as we age, our body's ability to produce these enzymes begins to diminish after age 35.
Oh, I'm just barely past that.
Oh, yes, I know. You just started the downhill move.
And real quickly, amylase. This activity begins in the mouth when we chew our food. Our mouth is very alkaline. And because it's alkaline, that activates the enzyme amylase. And it works on carbohydrates, sugars. It doesn't stop working in the mouth, though. It becomes inactive in the presence of acid. You know, the mouth is alkaline. The stomach should be very acid. But if the food hasn't gotten completely broken down, the sugars, the carbohydrates, it will reactivate in the small intestine when the pH again becomes alkaline.
Yes. Then there is protease. This is the second major of the three. Protease works to digest proteins by causing the protein to break up into its amino acid parts. The work of hydrochloric acid in the stomach prepares the proteins for pepsin, which is another enzyme which is in the stomach. In fact, it is the most powerful protein breaking up enzyme that we have. But it only is released when the stomach acid reaches a certain point.
So if you take proton pump inhibitors, pepsin will not be released.
That's right, and you'll get poor protein digestion.
And if you don't have good protein digestion, you can't repair that ear.
Yes.
So this is really important.
So when the digesting mixture is emptied into the small intestine, then even more powerful enzymes attack the protein-based foods we're going to get to here shortly to prepare them for absorption through the villi of the small intestine. And
that then enters lipase. It's an enzyme that works to break down fats, as we talked about before, into glycerol and fatty acids. And its work begins after the acid bath in the stomach, when the digesting food moves into the small intestine.
Yes.
And the pancreas comes into play here in just a minute in the small intestine. This is when the real good part of digestion happens.
So here's kind of just a review of what we're talking about. Carbohydrates start their breakdown in the mouth through amylase. Proteins start their breakdown in the stomach with hydrochloric acid, and then pepsin, and then protease once it reaches the small intestine after it leaves the stomach. And then fats don't really get digested until the small intestine when they get introduced to lipase.
They're tagged in your mouth and with your parotid glands here, and it tells everybody downstream, hey, there's fats coming down. Your gallbladder starts to contract. It's just the coolest orchestra that happens.
The bile will emulsify the fats, which means to make the fat so small it will mix with water. And then lipase just
Comes
rips
in and
those
just
fats to pieces.
Rips them to pieces. So you can use them. All of our body, every cell membrane is fat based. I mean, the fatty acids.
The brain is more than half fat.
Yeah. So it's very critical we get fats into our body. And for years and years and years and years, I never ate fat. I would not touch fat. I wouldn't have even tuna fish sandwiches with mayonnaise because the fat I couldn't stand. And la-da, I showed up with breast lumps at 36 years old. Yeah. Many, many, many breast lumps. They stopped counting them at 17.
Well, some of you probably wonder what the pancreas looks like. Here we have in the middle of the picture, pancreas, our pet pancreas.
And just showing you that it produces the lipase, the amylase, the nuclease. This digests nucleic acids, which are the DNA and the RNA.
Right.
When you eat a steak.
Yeah.
You got
yeah,
that?
because you do not want the DNA of another life form.
Oh, no.
Or even another human, for that matter, getting into your bloodstream. You want your DNA, nothing else.
How would you, licking blood or something? I
don't know.
I don't want to go there. Yeah.
But nucleases are one of the minor types of enzymes made by the pancreas, and that's its job, is to break up nucleic acids. And then there's trypsin, chymotrypsin, and our carboxypeptidase.
Ooh.
These, again, are more digestive proteins aimed more at heavily proteined products. And then there's amylase going after the carbohydrates to break them into sugars.
Yeah, and I got a little link down there.
And following Dr. Lee's philosophy, using whole foods as a source of nutrients to ensure the fact that all the unknown elements of health are included, we have made sure in our products to include the whole desiccated gland, to ensure the fact that all the minor enzymes have been included, though they're not listed on the label.
So the whole pancreas, the desiccated pancreas,
is in our product.
The porcine desiccated pancreas, which is very critical, not bovine, because bovine, they're not...
Their pancreas isn't oriented towards proteins.
Yeah, they're not carnivores or omnivores like we are. So we used a pig, which is the most... I just read an article the other day. They're trying to make a synthetic pig to make organs for donation.
Yeah, for humans.
Yeah. Synthetic. I don't know. Frankenstein stuff. Okay, then enters the all-important pancreas in the small intestine. And these are two of the very most important enzymes in your body. This is what keeps us alive, keeps us from mutating and turning into monsters. Keeps cells from going wild and crazy, these trypsin and chymotrypsin, and there's many, many more.
Well, it's at this point that the trypsin and chymotrypsin, pancreatin, many, many more enzymes known as pancreatic juice are released through the pancreatic duct to decimate the solid foods that are remaining from the stomach, except for plant material, because the pancreas does not produce cellulase. I mean, this means the cell structure of plants cannot be digested in the human system.
Yeah, this is really critical. This is when the pancreas produces these very strong trypsin and chymotrypsin. And I'm trying to think of an analogy where when you're making a bomb, but you can't mix the two chemicals together, and the minute you do, they explode. And this trypsin and chymotrypsin are unactivated, of course, in the pancreas, or it would eat the protein of the pancreas. But until they come out, and then they just eat the food that's in your small intestine. Yeah. But one thing the pancreas does not make is cellulase. We don't make it at all. And we have a very hard time breaking down plant material.
Which is one sometimes you can eat a very big salad or series of salads, and you notice something funny about the stool.
Yeah, you see many of my older patients would tell.
You'll see the salad material in the stool.
They said it came out the same way it went in.
So here's the difference between an herbivore and an omnivore that's human, because the enzyme cellulase is produced by the bacteria that exists in the digestive systems of herbivores, such as a ruminant.
We don't have that bacteria.
No, we don't, because we have hydrochloric acid. That bacteria could not survive in our stomach. Our stomach is designed to break down proteins, mostly dense proteins. particularly that which you get from meat.
Yeah.
And cellulase that digests cellulose is an enzyme produced by the fungi, bacteria, protozoa that live in all the different chambers of a ruminant. Now, a horse is not a ruminant. A horse has just one big stomach, but it's full of the same kind of bacteria that breaks down the plant material.
It's not full of acid.
No, it's not full of acid. It's full of these bacteria in a much lighter acidic situation, much lighter.
That's why these animals, though, have to eat all day long.
Because it takes all day long to break that stuff down.
The stomach, I mean, the cow has 4 different stomachs there. I'm learning this right along with you. This abomasum and the omasium. Did you learn about these? You studied bodies, not cows, but...
Yeah, this was kind of on the side. But this is why deer, cattle, sheep that are ruminants have these several different chambers or rumen. And there's a different concentration of microbes that produce different forms of cellulase, and they have to eat all day long, as you said. We, on the other hand, need very dense foods because we have to have time to create.
Yeah, I had this vegetarian tell me one day that he was so proud of himself. He says, I eat every 2 hours, And I said, well, when do you have time to create? Dr. Roy Lee said this. He said, we need very dense nutrition. We need to eat the thing, to eat the thing, to eat the thing, to eat the thing, to eat the thing. We're at the top of the food chain. So we have time to create. So we eat lots of fat because it takes a long time to digest that, and it keeps us satiated for a long time. So we have time to make space shuttles.
So here you have a cow with several stomachs. By the time the grass has been consumed, and what do cows eat? Well, they're supposed to eat grass. Grass, herbs, and flowers. Mm-hmm. Sheep, what do they eat? Deer, what do they eat? The same things. What happens when you feed these animals grains? Well, they don't really have the bacteria that's designed to break down grains, so you get fermentation. And what happens in a cow when its food ferments?
Is this the carving stuff they're talking about?
I just imported that from a cow. Yeah, and so they talk about how farms are producing all this methane, but that's because they're feeding grain to cows, and they're not supposed to be eating grain.
You ever see a cow walk over to a row of corn and
leave the grass and start eating the corn?
Chomp down on the corn?
So, I mean, it's interesting. I mean, even herbivores get their energy from fatty acids because that's the byproduct of the bacteria breaking down the grass.
That's interesting,
Just
isn't
as
it?
omnivores and carnivores do get their energy from essential fatty acids. So even your favorite horse is living on a high-fat diet, even though you're feeding it alfalfa, you're feeding it grass.
And then we eat, not the horse, mind you, we eat the cow, unless we're desperate, then we might eat the horse, but we eat the cow and we get those fatty acids.
Yeah, in a concentrated form.
And I'll tell you what, we try to feed our little kitty, Lucy, broccoli or vegetables or anything, and she won't even touch it. In fact, she won't touch cooked meat.
No.
Rourke had a sandwich the other day, had salami and stuff and turkey cooked. Well, I don't know if the salami was cooked. But anyway.
It might have been prosciutto or something like that.
But she just won't. And, animals, they...
Yep.
So anyway, so that's really interesting. And you need to understand that about enzymes and how plants carry their own enzymes inside of them to break themselves down. And
aid the digestion of these animals, or aid the digestion in a human. Because when you break open the plant by chewing and chewing until it's soup, these enzymes are released.
Yeah, or you cook it, or you dry it, and crush it, and do all these different things, or put it in a juicer. Okay, now that was pretty simplistic stuff. I think a lot of you knew that. Now we're going to get into some little more deep.
Yeah. And we're going to talk about Dr. Gonzalez and pancreatic enzymes.
Yeah, this is an article that I've given out before, but if any of you know anybody that has cancer, or especially pancreatic cancer, this handout will be available at the end of the podcast, and it is jam-packed with information. This is Dr. Nicholas Gonzalez, and he's talking in this very incredible article about pancreatic enzymes. And he said, I didn't come up with the idea to use pancreatic enzymes to treat cancer. The Scottish embryologist Dr. John Beard, who worked at the University of Edinburgh in Scotland at the turn of the 20th century, first proposed in 1906 that pancreatic proteolytic enzymes, in addition to their well-known digestive function, represent the body's main defense against cancer. So he's saying, I didn't come up with it. Dr. Beard came up with it 100 years ago. Dr. Beard further proposed that pancreatic enzymes would most likely be useful as a cancer treatment.
Yes, over 100 years ago.
Yeah. So here's another article, the Gonzalez Therapy and Cancer Collection of Case Reports, tells you how he used the proteolytic enzymes.
Yeah, he said this. This is quote, during the first 2 decades of this century, a number of physicians, both in Europe and in the United States, used injectable pancreatic enzymes to treat advanced human cancer, oftentimes, depending on the quality of the product, with great success. I have collected a number of reports from that time in the major medical journals documenting tumor regression and long-term survival in patients treated with enzyme therapy.
Now, it's really critical here. He said, depending on the quality of the product, he treated them with great success. And we're going to get into that in a minute, but that is really critical. It took him almost 100 years to figure out exactly how to do this because there was no grants. The government didn't fund any of this. There was nobody, they were just working. Poor Dr. Beard that you see right there, never married, and he died all alone, and all he did was work. But
by the time he died, there were about 40 clinics in England using his method for cancer treatment.
Yeah, and he had a few things wrong too, we found out, and even further doctors that used it through the whole 20th century did some things wrong that Dr. Gonzalez figured out. And here it is, what went wrong, Dr. Gonzalez. He wrote this incredible book, The Truth Behind the Clinical Trials of the Enzyme Treatment of Cancer. He got really stymied, or he trying to do this huge, gigantic study for 20 years, and he got tripped up every which way. They would give him patients that had gone way too far in their cancer, because these were pancreatic cancer patients. They didn't have a lot of time, or all kinds of other problems they couldn't swallow, by the time he got them. And so the studies didn't come out the way...
Yeah, they gave him not what walked in the hospital, but the worst of the worst.
Yeah.
And we go into this much further in podcasts 67 and 68.
Yeah, those are 2 great podcasts.
Much deeper in those.
So he goes on and says, Dr. Gonzalez says, there are several studies from the 1960s showing in an animal model that orally ingested pancreatic enzymes have an anti-cancer effect. And he said it's clear from our extensive clinical experience the pancreatic proteolytic enzymes, that means they break up protein, they chop up protein. Proteolytic enzymes have a profound anti-neoplastic, did I say that right?
Yeah.
Neoplastic effect, meaning anti-cancer.
They
Neo
destroy
meaning
the neoplasm.
Yeah.
New tissue.
That's why it was neoplasmic effect is what I thought it should say. So that's an incredible book to get. I don't know if you're an angry person.
Well, we have it, and I've enjoyed it because these are people who he went from all the way through with strong clinical background, hospital testing, biopsies, scans, imaging to prove of what situation there was, and then how the establishment messed it up to make sure they had
you would
bad
think
results.
This would be like a viral plague, that they were working against the clock. It's 11:59 and we've got to stop. We've got to figure out this cancer problem. My mother is dying.
Yes.
But no, they tripped him up, and that's why he's not smiling in this picture. What went wrong? It's just very, very sad. So let's move on to Dr. John Beard. Actually, we're going to go backwards. He wrote this book in 1911, The Enzyme Treatment of Cancer and Its Scientific Basis.
And he talks about his laboratory experiments with animals. And Dr. Beard found that during embryogenesis, which is the formation of the embryo,
of life,
many of the newly formed stem cells do not end up within the placenta itself, but they migrate throughout the various developing tissues and organs of the fetus to form undifferentiated nests of stem cells that remain in place for the duration of the person's life. Now, let me put that in street language. What he found, in embryogenesis, what happens is when the sperm meets the egg, it becomes, as you know, it becomes a fertilized ovum. That ovum will split into 2 cells. Those 2 cells do not split into 4, they split into 3. Those 3 do not split into 6, they split into 4. Then those 4 split into 8. And at that point, these 8 cells are known as something as totipotential, which means any one of those 8 cells can form a human being.
Wow.
If there was some way to take those 8 cells and implant them into 8 different uteruses, you would have 8 exactly replicated human beings.
Is this redundancy? Maybe?
Well, for Beethoven... if we'd had 8 Beethovens, 8 Mozarts, 8 John Lennons.
Life will find a way, and this is the redundancy they set up, just like a RAID system on a computer.
But what happens is that when you form these 8, what happens at this point is that by this time it's gone through the fallopian tube, it's ready to implant in the uterine wall, and an amazing thing takes place. These 8 cells are going to become 16, and they split into 2 things. One is the outside wall called the trophoblast, and the inside will become the fetus that will develop into the baby. And these trophoblasts are cells that are going to form the placenta. And what Dr. Beard found is that amidst all of these trophoblastic cells, these cells that become placentas, the placenta, there were thousands of variants of those things that ended up going throughout all the tissues of the body.
Just like little gold things just depositing everywhere.
And that's where the stem cells came from in early fetal development. Now, we have stem cells that are being produced in bone marrow in our bodies while we're alive and in other places. We have stem cells throughout our whole body, but this was an incredible discovery published in 1911.
Which was ignored.
When we said that this, this podcast, if you have cancer, your doctor won't tell you this. This is this we're talking about.
They don't even know this.
No.
This was 100 years ago. They understood, more than 100 years ago, how both tumors and mutated stem cells, although they didn't have the term stem cells back then, stimulate new vessel formation, like blood vessels, to allow for survival. It eats into the wall for a blood supply, because if it doesn't do it, I forget within how many days, then it dies. If it doesn't eat into
if it doesn't implant, sometimes in a matter of hours.
Yeah, it's got a short window there.
Because it needs nutrition.
Yeah, but it's got enough nutrition to last for, I forget how many.
Well, the endothelium
4 days
of the uterus is putting out nutritional substances that this thing is trying to absorb before it can invade the uterine wall and get its own blood supply.
And what does that sound like? Ooh.
Something that's not quite as pretty as a baby.
No. Really, really ugly.
We'll get to that in a minute.
Yeah. So it stimulates this new blood vessel formation to allow it to survive, and it produces an enzyme called malignin. Now, we don't like that word, malignin, okay? It eats into healthy tissue to establish that blood supply. So what they think happens in a cancer-type tumor is that it produces that enzyme called malignin that eats into it, and then the enzyme trypsin comes in and cuts off that blood supply, and chymotrypsin comes in and finishes off and destroys the tumor by liquefying it. This was stated and proven by Dr. Beard over 120 years ago. So
now, what's this got to do with cancer?
Well, that is cancer, because it's not self. And we explained this in the other podcast Jack mentioned earlier, where it goes in and it recognizes living cells versus dead cells versus right-hand cells versus left-hand cells. Yeah, we're not going to get into all of that. But after years and years of research, Dr. Beard came to the conclusion as how to enzymes destroy cancer starting in the embryonic pancreas. And this was in every mammal species that he studied. So if you want to jump in here, what happens? Well,
the very day that the placenta that came from the stem cells converted from this very poorly differentiated invading tissue into the uterus, trying to get its own blood supply. At the day when that stopped it became a mature placenta, which happens to be day 56 in humans. Then the embryonic pancreas begins synthesizing and secreting its whole coterie of digestive enzymes. 56 days.
I mean, look
We're
at that.
talking 8 weeks.
That's not a
We're
baby.
talking 2/3 of the way through the first trimester. All the organs haven't even formed yet, and yet the human embryo is releasing digestive enzymes into the bloodstream.
Aha. Why would it do that? It's not eating food.
No, it has no food in its digestive system. You know, towards the end of its gestation, it might swallow some meconium or some embryonic or amniotic fluid. But there's no hamburgers floating around inside that amniotic sac.
Not yet.
So why are these enzymes being released? This is what is so cool, because there's nothing there to be digested. Well, Dr. Gonzalez continues in the work and the discovery of Dr. Beard's life-saving work. Quote,
But, okay, are you going to go into that? Because I wanted to explain this first.
oh yeah, go ahead.
Yeah, you can jump in any time. The reason it needs to stop invading and growing
What needs to stop invading and growing?
the placenta.
Yes.
Because what would happen if the placenta didn't stop growing?
The placenta is
It'd be a
going through
tumor.
explosive growth the first few weeks of fetal development. And then all of a sudden, on day 56, it slows down
Yeah.
and becomes a mature placenta. It'll grow bigger. It'll develop what are called cotyledons, 12 of them, in order to get nutrition from the placenta and debris or garbage from the baby, you know, the cellular respiration byproducts back out of the baby, back into the mama's bloodstream, out through her urine.
Still doing all of
Still
that.
doing the exchange stuff.
But it's not growing exponentially.
Now, there's a cancer called choriocarcinoma.
Very
That
rare.
happens, very rare, but it happens when the placenta does not stop its rapid growth.
When the little baby's
And in a
pancreas
matter of
doesn't
days
release
to a
trypsin.
week or so, it will kill the mother and the baby.
Yeah.
There's nothing you can do for choriocarcinoma. Now, what's happened here is that when conception takes place and when the morula, when you've got about 8 cells and it bursts out of its little cellular wall that's been containing it from the original ovum, and it forms this morula, which in Latin means mulberry, because it kind of looks like a little mulberry, a bunch of bumps. At this point, the malignin that you talked about, which is an enzyme released by cancer cells to invade an epithelial barrier to get into a blood supply, that's exactly what the fertilized egg does. Once it gets to be to the size of about 8 or more cells, it starts releasing malignin. And the malignin eats through the uterine wall. Now, the crazy thing about it is the hormonal changes that take place when conception occurs 8 to 10 days earlier. The uterus is already down there putting all these little tiny hairs called pineal sticking out of the wall of the uterus, microscopic little hairs. Here, we got your back. We're here to catch you. And so the egg falls out of the opening of the fallopian tube, supposed to go to the posterior wall of the uterus. All these little pineal are there holding on to it. And then it releases the same exact enzymes, matrix metalloproteinases, that cancer cells do to dissolve the host tissue to get to a blood supply.
It starts eating.
Now, what does the trypsin do on day 56 once it gets into the bloodstream?
It cuts it off.
It stops that from happening.
It stops that from happening anymore and saves a mother's life, produces a beautiful baby.
It destroys those cells putting out the matrix metalloproteinases.
Those proteins.
So that stops, the invasive growth stops, and now the uterus is locked onto the placenta is locked onto the uterus, the baby can develop.
Who did this? Who figured this out?
I think a lightning bolt hit a primordial pond 2.5 billion years ago and created a protein.
Those monkeys.
That's what my science teacher taught me. Yeah. And this is so incredible. And
this was ignored.
It was ignored to a large degree, rejected heavily by the medical community, which brings up that famous quote from Schopenhauer.
First, it's ridiculed. Second,
All truth
I skipped the
passes
first
through
part.
3 stages.
First, truth is ridiculed. Second, it's violently opposed. And third, it is accepted as being self-evident, except for this has not been accepted.
It hasn't reached the third stage
Your
yet.
doctor doesn't even know to
Now
tell
it's
you about
violently
this.
opposed.
So Dr. Gonzalez, I'm just going to quote him because he's just so great here. He says, though the rejection of something new in the scientific research community hardly seems surprising, it is, of course, the historic norm, that you made something new in the scientific community. He said, I find the ultimate indifference toward and contempt for Dr. Beard evident in his contemporary academic colleagues, most unfortunate. Dr. Beard was, after all, an impeccably trained scientist, a professor at an eminent European university whose
Embryological.
I just
That's
don't know why.
It's a big word. It's
I trip
okay.
over those words, embryological, if I say it fast. But he was an impeccably trained doctor whose I can't.
Embryological findings are still accepted in the texts of our day. What he discovered, researched, and wrote about over 100 years ago is still current in texts. He carefully documented his laboratory and clinical results that he published in the conventional medical literature, but it seems to have made no difference at all. End quote. That's from Dr. Gonzalez.
No difference at all. So Schopenhauer, the third part, is not happening yet. That is being accepted as self-evident.
Yes.
Okay? So that's just a brilliant, incredible thing Dr. Beard discovered. And he said, this has got to be the answer to cancer. So
these are the books that Dr. Gonzalez is. This one is open right here on my study desk, right here to my left, the Trophoblast and the Origins of Cancer.
Yeah, this is a brilliant little book.
Yeah.
If you have time to read it. In it, there's a discovery that, of course, I'm not trained in this, but I don't know that there's any doctor that knows this either. I hear doctors talking about this, that cancer comes from old, dead,
They're dying just
mutated
cells that go with Alzheimer's, wacko, murderous.
Yeah, but what Nicholas Gonzalez discovered here is that cancer does not develop as so long thought from mature healthy cells that suddenly go molecularly berserk, transforming into cancer. Instead, the investigators are showing in this study in the University of Michigan that cancer develops from stem cells that lose their normal regulatory restraint.
Right. Now, stem cells are throughout the entire body. They're in your heart. They're in your eyes, their liver, the kidneys, the ovaries. And what these stem cells do is they become new cells of the tissue in which they are hosted.
They mature.
Because local growth factors are then released by the other mature cells that trigger the stem cell to become a heart cell, to become a liver cell, to become an ovarian cell. And they have the ability to do this very, very quickly. And so they have a normal restraint wired inside of them. So they wait, and they wait, and they wait till their number's called, then they become a new cell. But when they go berserk, it's like a tied up coiled spring inside of them. Boom! They blast into cancer cells.
And we're not even studying this.
Well, there are a few places that are studying it, but it's not being funded by the NIH, and we'll get to this in a few minutes, because the NIH only funds things that aren't controversial.
Yeah. So this was a small study in 2002 with Dr. Wicca at the University of Michigan, and is actually with multiple institutions. Oh, so it has been happening. I didn't realize this. It has been happening. And
Yeah.
Multiple institutions have been demonstrating that cancer does not develop as so long thought from mature, healthy cells.
Mature, crazy cells.
That just go molecularly berserk.
No, they come from stem cells.
Okay.
That lost their normal regulatory restraint. In other words, the thing that's holding them back until local growth factors, protomorphogens, trigger them into becoming the same tissue as their host.
And we have talked about protomorphogens
we've talked about it many
endlessly
times,
and it's a standard process type.
So
product.
Dr. Gonzalez goes on here and says this, as part of my project, I'm quoting directly.
Well, he studied another doctor, and this is Dr. Kelly, that actually didn't even know about Dr. Beard and stumbled on the pancreatic enzymes, and then later on found out about Dr. Beard. So Dr. Gonzalez studied under Dr. Kelly.
Yeah, Dr. Gonzalez was a medical student studying cancer at Sloan Kettering in New York City, and was set out on a project to go study the work of Dr. Kelly down in Grapevine, Texas. And so Dr. Gonzalez says this: as part of my project, I eventually interviewed and evaluated more than 1,000 of Kelly's patients, concentrating on a group of some 455 patients diagnosed with cancer who had done well under his care. From this population, I wrote up in detail 50 cases, 3 representing 26 different types of cancer. Even today, nearly 30 years later, I'm still impressed by Kelly's achievement. For example, one of these patients, a woman in Wisconsin, was diagnosed in August 1982 with metastatic adenocarcinoma of the pancreas, the worst form, with biopsy-proven metastases into the liver. The Mayo Clinic confirmed the diagnosis, offered no treatment, told her she might live 12 months. With no conventional options recommended, she began looking into alternative approaches, learned of Kelly, began his treatment. I first interviewed her in 1986, 4 years after her diagnosis, as part of my Kelly investigation. At the time, still following her nutritional regimen, she reported feeling quite well. In the many years since, we have kept in touch regularly, and today in 2014, she is alive and well and as feisty as ever, now 32 years from her original diagnosis. Wow. I have searched the literature repeatedly and know of no other similar patient with biopsy-proven liver metastases from pancreatic adenocarcinoma documented at a major institution, alive and well, 32 years later.
And this book I just popped up on the screen talks about that.
Then another patient was initially diagnosed, and I'm still quoting from Dr. Gonzalez. Another patient was initially diagnosed with adenocarcinoma of the uterus in 1969. Because of the large size of the tumor, her doctors advised a course of intensive radiation therapy before hysterectomy. Because her doctors thought the disease was localized, post-operatively, no adjuvant therapy was suggested, which would have been chemo. However, by 1974, her general health had deteriorated significantly. She experienced unrelenting fatigue, severe depression, weight loss, and vague abdominal pains. Initially, her physicians attributed her symptoms to nerves.
Oh, don't you love it? Oh, you're hysterical.
You're just nervous.
Yeah, let's do a hysterectomy.
But when she developed a grapefruit-sized tumor in her pelvis, she was referred back to her surgeon.
They believed her then.
Yes, at that time, an X-ray revealed multiple tumors in both lungs consistent with metastatic disease. Her surgeon recommended palliative resection of the pelvic tumor to prevent an impending intestinal obstruction.
Meaning this won't cure you. Palliative means it's just to kind of make
to take care of the immediate problem.
Be more comfortable.
Though he admitted to the patient she had an incurable disease. With no further options, she began investigating alternative treatments for cancer. After learning of Dr. Kelly, she consulted with him and followed her prescribed nutritional program religiously. Under Kelly's care, her health gradually improved. She avoided all conventional doctors for a time, but 9 years after starting her regimen in 1984, she returned to her former primary care physician for an evaluation. The physician, as the records indicate, was astonished that she was still alive. A chest X-ray confirmed total resolution of her previously described multiple pulmonary nodules. Subsequently, she kept in touch with me periodically until her death in 2009 at age 95.
95.
34 years after her diagnosis of metastatic disease, some 40 years from her original diagnosis. Again, to put her case in perspective, I have searched the literature and know of no similar patient with recurrent endometrial cancer who experienced total regression of disease and survival of 34 years after the appearance of extensive metastases.
So it had metastasized.
To the liver.
Malignant.
To the lungs.
It was gone.
Usually when that happens, you're gone.
Yeah. What with pancreatic, now she had endometrial cancer.
Adenocarcinoma in the uterus.
But still, it's just so amazing. And what Dr. Gonzalez, the guy in the middle picture, and Dr. Kelly, and then the slide before, Dr. Beard, and there are a few other doctors too, we're not going to go into them. They used proteolytic enzymes, pancreatic enzymes.
Right.
Along with a diet.
So we've talked about digestive enzymes, amylase, protease, lipase, but there's other enzymes produced by the pancreas that just by some series of accidental discoveries in the early part of the last century and the latter part of the 19th century, pancreatic enzymes are released by the mammalian pancreas long before the fetus, the baby, the pup, the kitty, whatever else, long before they're ever eating anything. Pancreatic enzymes are being produced and released into the bloodstream.
To stop metastases.
To stop the development of cancerous cells.
Yeah. So they translated that over into cancer treatment for them. They're medical doctors. Unfortunately, very unfortunately, Dr. Gonzalez died in 2015. Just died. Nobody knows why. He on autopsy did not have a heart attack, did not have an aneurysm, was not poisoned that they could find.
Yeah, he just dropped dead.
Somebody took him home, I guess. And he dropped dead. And he hadn't finished writing this book, Nutrition and the Autonomic Nervous System. But which is, it's so incredible that this was just published. His wife and Dr. Linda Isaacs, who he worked with for 25 years, helped get this book out. And this is the book that tells you how to balance out the parasympathetic and the sympathetic system so you can become a balanced person. It doesn't just go into proteolytic enzymes. It goes into the diet, and it goes into what type of metabolic person you are. They made a scientific, they call it the Scientific Foundations of the Gonzalez Protocol. Really, that's what they call it. It's a groundbreaking book, Dr. Nicholas Gonzalez. He explains the importance of nutrition in maintaining and restoring the autonomic nervous system balance. And that's so crucial for good health. It's not enough to just get rid of cancer. You need to be healthy. You need to live life. And that's what he brought him back to.
So here, they had to put this, even though he's an MD, or was an MD.
And he was a cancer.
And a cancer MD, they still stick this disclaimer in there because you have to be very careful about this. You've got the NIH, the FDA, the CDC, the FTC, all are pretty well controlled by big pharma, and they will stop anything and everything that threatens the use of drugs and surgery for every kind of problem we have. The NIH, National Institutes of Health, only give grants out to non-controversial studies. The FDA, of course, is watching what is on labels. The CDC, of course, is just a vaccine company. They own 56 vaccines. They're totally sold out. The FTC, the Federal Trade Commission, is looking for what kinds of claims people make. So don't say that your life is dependent on oxygen unless you have volumes and volumes of randomized double-blind studies to prove it. So this podcast title is, If You Have Cancer, No Doctor Will Tell You This. Well, these last three slides are the this, which we're talking about, which basically boils down to autonomic nervous system imbalance, which leads to either the sympathetic, which is the fight or flight or freeze part of your nervous system, or the parasympathetic, which is rest and digest, overrides one or the other, which leads to immune system suppression, which allows these mutant stem cells to grow. Now, we have these mutant stem cells in us all the time, but it's a healthy, resilient, proactive immune system that keeps these mutant stem cells at bay. And your oncologist is not going to tell you this because they don't read the literature.
And here is
literature? What literature? Here's the literature sources for the reports we just gave you.
Now, I have to tell you, this is the resources from just that paper article.
30-page article, I think.
Yeah, it's about 36 pages.
Here's all the research that went into it.
Just from that article. The book is just, it's this thick with references. So this is the literature that your doctor won't read.
That supports the pancreatic enzyme therapy of cancer concept.
Yeah, and you can take any one of those and literally just type it into Google And the study will come up and it will tell you the most amazing things, like number 35, pro-enzyme therapy of cancer. And this number 36, Gonzalez and Dr. Isaacs, the Gonzalez therapy in cancer, a collection of case reports. That's the one I had. I'm going to have that actual number 36. I'm going to have that one as a handout at the end of this podcast. And there's just so many there if they could just read it. And that's just from that handout. So what we've gone over is some very simple things, simple enzymes for the proteins, fats, and carbohydrates. And then we got a lot deeper with the proteolytic enzymes that actually go in, stop the malignan that is an enzyme that appears in a tumor from eating into your body, stops it, and then the chymotrypsin comes in and liquefies
the tumor.
Yeah. But we've gone on an hour now, and so we decided to break this into two parts because the pancreas does more than just
digestive enzymes. And that's where we're going to get in the second part.
The pancreas is an amazing organ in that it is both an exocrine gland and an endocrine gland, meaning it produces enzymes.
Insulin as an endocrine gland.
As an endocrine.
Then it produces all these other enzymes as an exocrine gland, which means it's released at the point where the gland makes it.
Mm-hmm. So we decided to make this two parts, and so it will be continued next week.
We'll zip through these last slides here for you.
But before we do that, we do want to mention that our Long Life Energy Enzymes has the same enzymes that Dr. Gonzalez uses with his patients, or did use with his patients. And
so why would you want to use these things? Well, we're not suggesting that you use them for cancer. That was the most dramatic discovery, I think, as far as enzyme therapy of the last 100 years. Here is the reason why we created Long Life Energy Enzymes.
I mean, just the first one.
And these are the reports we're getting back from patients who've used these things.
Yeah, slows the aging process. The hypoglycemic support, which we talked about a testimonial a couple weeks ago, I think, somebody that had a lot of hypoglycemic or pre-diabetic type symptoms, and they were eliminated. Pancreatic support, heartburn, I mean, that's huge. Heartburn, food breakdown, complete digestive support, sugar cravings. We have, I have it right here. Got a paper right here. It says, my major health problem was craved sweets. I've been taking the Long Life Energy Enzymes for over a month. My craving for sweets is gone. I feel much better when I'm taking these pills. That was from a patient in our clinic.
All right.
And gut dysbiosis, achy joints, really critical for a lot of people. This will clear out those achy joints. All the toxins that get deposited in your joints, as Dr. McBride says. Morning person problems, people that can't get up in the morning, take 3 of these and it's like they're going with energy. Because remember, the enzymes create energy in your body. Insulin, dependent support, dementia, Alzheimer's, and much, much more. Here is a list of the actual ingredients that are in the product. We're going to go over that a little bit more in the next podcast, but it's got the whole desiccated porcine pancreas powder from a pig. And then, of course, the herbs, and it's got kombucha, it's got, chlorophyllin. We don't have time to go into each one of these, but you can pause the podcast and read it here, or the handout will be at the end. One more quick little thing is that enzymes are also for pets. This is a great little article. I've got a link right there you can go to. I got it from AARP, which I violently disagree with most of the time. But they did say in this article, because we have a new pet, I was interested in it, but they said 50% of all dogs over age 10 get cancer at some point. So our little kitty's only 2 or 3 years old. We're not sure how old she is because she just showed up on our doorstep one day. But we put our Long Life Energy Enzymes, we sprinkle them on her food. If she looks like she's having any gastric distress, we put her in a little, I guess they don't call it kennels for cats, but we put her somewhere for 10 days and she had some digestive problems because they changed up her food and stuff. So this is important because they had to tell a story about a lady that's spent nearly $31,000 in 23 months to save her dog Lily. So she said it was probably not the best financial decision I ever made, but I mean, I shouldn't laugh. It's really sad.
A lot of people, when they're there and they find out their dog or their cat or whatever else is terribly sick, a lot of them will just pull out the credit card and say, "Save my dog."
I know. It's
Save
so
my
sad.
cat.
Yeah. Well, her dog had all her health saga problems start from a rare severe reaction to a rabies vaccine, which caused brain and spinal cord inflammation. We just finished 2 podcasts on vaccinations. So, that goes for your pets too, and so do the enzymes. We'd love you to join our family by filling out a symptom survey and let us write you up a no-obligation nutritional protocol designed specifically for you, especially if you're having any abdominal distress, digestional, or even something worse than that, or you suspect something worse than that. Please jump on our website, forbiddendoctor.com. You'll get a free username and password. And when you sign back in, you'll see your very own supplement protocol sitting there waiting for you. Couldn't be easier than that. And just want to do the disclaimer at the end of our podcast. Always have to do this. Always have to protect ourselves. And take it away, Jack.
The statements made in this webinar about specific products have been evaluated.
Have not.
Let me start that again. The statements made in this webinar about specific products have not been evaluated by the United States Food and Drug Administration and are not intended to diagnose, treat, cure, or prevent disease. All information provided or any information contained on or in any product label or packaging or this webinar is for informational purposes only and is not intended as a substitute for advice from your physician or other healthcare professional. However, I'd recommend that you get those books if you have cancer or someone you know or love that has cancer. Get those books and take them to their cancer doctor.
Yeah, see if they'll read them. If you like what we're doing in these podcasts, there are several ways you can support us. You can leave us a positive review on iTunes or wherever you listen to these podcasts. At the end of this podcast, leave us a nice review there too. You can ask us questions and give feedback and comments from numerous places on our website, or even join our family again by filling out the symptom survey. So again, please leave us a comment or question at the end. And remember, you can always call, text, or email us, or come into our office with questions. We will help you. And we will see you next week with part 2.
See you then.
Thank you for listening to the Forbidden Doctor podcast. If you are curious about long life energy enzymes or ageless thyroid, you can purchase them without a membership from our website at forbiddendoctor.com or get our enzyme formula from amazon.com by searching the full term long life energy enzymes. Don't forget to take our obligation-free symptom survey to get a free personalized supplement protocol recommended for you by Dr. Jack, Mary, or one of our qualified nutritionists. Take the survey, get a call from our nutritionist to create a protocol and a patient login, then use that login to see your own personal protocol along with any favorites you've saved from our symptom library. Remember, our website and our clinic are here for you always.